Welcome back to the AWS studio here at Mobile World Congress Barcelona. I'm your host, Robbie Belson, and in this session, we get to do something a little bit different. If you've had a chance to join us in the AWS Village here at the Fira, we have 24 demos, 18 partners featured, and 17 customer stories. But not all that often we get a chance to recap that demo right here in the studio. And today we're in for a special treat with guests and industry experts from the Intel and AWS team. Thanks so much for joining us.
Thank you.
Thank you.
Start with a round of intros. Over to you, Alex.
Brilliant. Great to be here. Thank you very much. So I'm Alexander White. I'm with Intel, and I work very closely with AWS as a technology and solutions specialist, and really focusing around the network, the edge, and looking at how we can enable customer solutions and bring the best of AWS and the best of Intel together to create great solutions as we go to market with customers.
Thanks so much for joining us. And now on to our esteemed demo owner, Subhash. Thanks for joining us.
Hi, I'm Subhash Tarluri. I'm a solutions architect focused on ML. I work with telco customers worldwide and help them in their adoption of AWS ML.
And away.
My name is Awais Khan. I am a telco solutions architect working on telco workloads, helping customers bring the workloads on AWS.
So we got a lot to unpack here, and eventually we're going to get to what do I actually get to see on the show floor. But before we get there, let's talk AWS Global Infrastructure as we continue to rapidly expand to meet the needs of our customers. We have 36 regions today at the time of recording. We've got local zones, we've got wavelength zones, we've got Outpost, and we have the recently announced AWS Outpost family for telco specifically. So no shortage of choices that customers have. But today, we're going to take the well-understood domain of edge and apply it to the world of generative AI. A little more nebulous, but look forward to discussing. So maybe we start with you, Subhash. What's the AWS position on how we can extend generative AI and offer greater choice to customers across the breadth and depth of AWS Global Infra?
When we look at our edge infrastructure, there are two things that we normally go for. It's either far edge or near edge. Near edge is something along the lines of multi-access edge compute. And what we now want to focus on is far edge as well. This will be edge servers at the customer locations, or for the purpose of smart X, which could be smart manufacturing, smart industry, smart agriculture, etc. And also devices. So far edge would also constitute device. It could be mobile phones, any of the IoT devices. And this is where we see a lot of applications that we are looking at across the industry within the telco domain, with CSP as an enabler of such technology.
And I like the topology that you've introduced. You've got the near edge, which we might describe as maybe an AWS local zone, so something in a metro aggregation point. And then you have the far edge, which could be my mobile device, a handset, or router, and we'll get into all of those different flavors. But Alex, from your perspective, near edge, far edge, Intel's playing a role, particularly with AWS, right?
Yeah, absolutely. We truly have a collaboration which is cloud to edge and edge to cloud, and workloads really do deploy across that entire continuum. And it really is important to allow customers to have the choice around where is the best place to deploy our model, where is the best place to deploy the workload, and really having software and hardware which work together so that you can look at the application, how you can serve your customers best, and the hardware and the software will deliver that for you. And of course, the best of AWS services really give you the continuum, the APIs, the SDKs to go develop fast. And then of course, the Intel frameworks and open source ingredients really give you the freedom to build what you want to build and what your customers are demanding from you.
So with all this increased choice in infrastructure, Awais, I want to give you the floor for a second.
Yep.
What have customers been asking as they start to think about modernizing their workloads, as they think about hyper-personalization? What are some of the questions you've been asking that have led to some of our latest prototyping efforts?
Yeah, so one of the most of the questions that we get is how to securely, when you have this kind of distributed architecture, right, and where you have user data silos between edge and cloud, how to securely transfer these data between edge and cloud, right? So with AWS services like AWS site-to-site VPN and AWS IoT, in this particular solution that we are demonstrating in this year at MWC, we are showing how these services can be leveraged to build a secure transport between the edge and the cloud.
So let's bring this and anchor ourselves in a practical example. Subhash, one might be a use case where somebody needs multiple flavors of edge and generative AI in each of these disparate locations.
Absolutely. So one case of far edge application that we have specifically built is in the case of end subscribers of the operators. So how we were looking at a CPE router, a customer premises equipment router, and how we can make that as a smart edge device, which can handle a lot of the customer queries locally without necessarily having to for the customers to call the contact center. So if we look at if we look at any telco operator, 50% of their calls are related to either billing, payments, or knowledge inquiries. So we want to deflect all those calls and infer or respond to such queries locally within the customer premises without having to necessarily hit the cloud or the customers having to contact the call center.
And so the idea is to create a more cost-efficient workflow to provide those answers to customers. Mm-hmm. But I assume it's also because the data that answers the question is right there.
Yeah.
Is that what we're saying it was?
Yes, exactly, yeah. So, I mean, the idea here is to utilize the data in the best form and make sure we use the small language model to actually extract the relevant data, create summaries, and present it when it is needed, right? So.
One of the things that I find fascinating about your demo is we're going to extend the breadth and depth of AWS Global Infrastructure to distribute out all of these different large or small language models.
Yeah.
But we also want to leverage the existing, let's say, value chain and ecosystem of, let's say, telco network solutions. So like the home router can now play a role in this broader value chain. So Alex, from your perspective, how do we think about the role that Intel developed or Intel supported on-device, far-edge locations can sort of amplify the solution?
Absolutely, and I think really one of the key things is that with Gen AI workloads and looking at how you can extract the value of bringing together the local data, as we were just talking about on-device, and being able to inference that locally, it makes a huge difference from an overall kind of platform story to look at where the different use cases this can be deployed. And then kind of beyond that, in terms of the telco networks, how can they look at leveraging that open ecosystem to really make sure that no matter kind of what the form factor is, are we looking at UCPs in enterprise or customer routers at home, there's the hardware and the software capabilities to shrink down those models and to efficiently run the LLMs or SLMs locally on the device as well.
So if I can play provocative skeptic technologist for a second, I'm going to ask, well, wait a minute, what do you mean? I can run a small language model without accelerated compute on a router? How does that work?
Yeah, absolutely. And really one of the key things to getting Gen AI to be adopted for the masses and to make it valuable for everyone who is interacting with technology, it needs to make sure that running it efficiently, and we can run it on as many different platforms as possible. The edge is really a very diverse set of deployment characteristics, has a very diverse set of deployment characteristics. We're looking at different form factors, we look at different power requirements. And with that, we want to make sure that we're delivering software frameworks which really allow you to choose the right hardware to go and make that possible. And for a lot of cases, being able to do that inference efficiently on the CPU, use integrated accelerators, so utilizing the CPU, but also making sure you're making the most of all the hardware you already have, is really important to drive down the cost, increase the flexibility, and as we say, right, running this in a home environment seems like an impossibility even a few months ago, but we're really driving a complete story to make sure that that is possible, the technology exists, and we can make sure that the power usage and utilization is dramatically reduced, because that's important for home users, and it's important even at the data center scale as well. So
we and the device ecosystem as a whole get to inherit all of the transformation from the generative AI foundation models and just get to run that anywhere, anytime.
Absolutely, and there's huge amounts of customization we can do moving forwards as well. I think we're really at the starting point of this journey as an industry. We can look at how we can bring very specific models onto very low power devices, and also make sure that there's larger models to be able to serve that broader context. And having a common set of APIs, open frameworks, means that you write your code once, you deploy once, and then you get the flexibility and the efficiency improvements of having the right size model for your application.
You mentioned software frameworks. I want to try something because each of you brings something unique to the table. So if we're going to take the solution that was developed in the demo, you cover OpenVINO and the Intel developed software framework.
Yes.
Subhash, you talk about how we brought generative AI in the agentic workflow. And Awais, if you can talk about how we developed that overarching network to connect each of these components.
Sure.
Let's start with you.
Yeah. So, I mean, in this particular demo, right, the problem was we have this edge hardware, which is basically sitting right at customer premise, right? And however, now it is carrying some user data, right? So there is sensitivity around the privacy, etc., that typically customers have. They would say, hey, how are you securely transferring this data from the edge all the way to the cloud for analysis, etc.? So using AWS services like AWS site-to-site VPN, AWS IoT, we basically not only just extract the data, but we transport all the way back, because there's quite a bit of exchange happening between cloud and the edge, so that it can basically infer some of these guidances for the customers, right? So,
And then from your perspective, what are the key ingredients that you see from the agentic workflow as a whole?
I guess a couple of key aspects. One is hybrid edge cloud inference, and the other is agentic orchestration. So when it comes to hybrid edge cloud, we wanted to leverage the benefit of cloud, at the same time reduce dependency on the cloud to enable more local processing to improve the operational efficiency for our customers. So in this particular case, for the use case that we're trying to solve in terms of a home router being able to deflect all these calls, we are processing the sys logs of the router right on the device, and we have an ETL workflow that is processing these logs through a Llama 1B model, which is small enough to run within the constraints of the edge. And we summarize those logs and then send that to the cloud for cloud aggregation with rest of the customer 360 data. So that's one. On the cloud workflow, we have all the customer journey touch points, which is aggregated from different systems such as billing, payments, usage, etc. And we aggregate all that data and have a customer 360 profile. And for each customer, there's a sync that happens between the cloud and the edge. So what is now happening is the summaries that we create, rich text summaries on the cloud, which sync to the device, because there's a batch workflow that's happening in the cloud, we are now able to ensure quality of the output that we are able to get from a small language model such as a Llama 3.21b. And it's all, in fact, in order to fit the edge constraints, this model has been compressed. However, that has not impacted the accuracy of the responses that the customer gets, because the batch workflows that happen both in the cloud and on the edge server ensure that the quality is already maintained. So we are able to give accurate and meaningful and sufficient information to the customer.
So you've got foundation models talking to one another. You've got the data syncing from cloud to edge. Where is the role that Intel and specifically OpenVINO is playing?
Absolutely. So really, Intel plays across the entire spectrum here. And when we look at it from the edge perspective in isolation, what we're really doing is providing the inference engine and providing all of the tooling alongside that to make sure that your model can run efficiently and really to utilize the hardware which is at your disposal. So as you mentioned there, in terms of reducing the size of the model, having the ability to quantize those local models into integer 4, integer 8, really drawing down the compute requirements to run that model efficiently is really important. I think the second part when we look at OpenVINO is the inference server capabilities. So being able to integrate with deployment mechanisms like Greengrass and IoT Core, it means that we can orchestrate all of the model deployments, orchestrate all of the responses through HTTP requests, so that, as you have a local router in your own home, for example, what you're able to do there is integrate and communicate with a single endpoint, and then all of that orchestration. Am I running this model in the cloud? Am I going to run it on the edge because my data's at the edge? All of that can be automated, and it can be hidden behind a single endpoint. So as customers develop for that, the simplicity is there. but all of the optimizations, all of the low-level integrations are in place for you.
And so for the purpose of the demo, you might have a single router, a single hybrid and edge location, perhaps the cloud running the larger foundation model, but this scales immediately to 1,000 routers. And so what role can Intel play in creating the reproducibility and modularity of this solution at scale?
Absolutely. So one of the key things when we look at a model and how we can efficiently use it is to make sure that we can utilize all of the different data points from there, as well as making sure we're right-sizing the model. And because OpenVINO works with industry standards, we work with common frameworks in the AI space as well. It means that if you're running different models across different customers, if you've got a certain customer who is fine-tuned for a set of their customer base, it means that all of their deployment mechanism is the same, but they're able to be highly specific in the type of model, the fine-tuning, the quantization, and all of the different optimizations they're playing. I think the other piece as well is that different customers and different networks are going to have very different requirements. So being able to deploy this on small form factor home devices, all the way through to even running this at a large enterprise level where you're maybe running much more complex queries, trying to debug more kind of complex issues which might require even more data. You've still got that single pane of glass, you've got that single API endpoint, and all of the optimizations feed through the back end there. So you're really taking advantage of the hardware, and you have the flexibility of the edge ecosystem to pick the right hardware and let the software in the background, the frameworks, align the best model for you.
And of course, behind each of these stories is even deeper levels of technical integration that we'll include in the show notes. But let's up-level the conversation for a bit and just talk about the use cases. So for the non-hardcore data engineers and network engineers tuning in, let's boil it down to the two questions that we might be demoing, like, help, my Wi-Fi isn't working, or I don't understand my bill. Are those two representative questions? And if so, like, what happens?
Right, so that is correct. So we are doing our edge inference in multiple far edge devices. So in addition to router being one of them, we are also doing inference off of a mobile phone. So what that means is through a single interface for a customer, if the question is about Wi-Fi troubleshooting or parental controls, being able to manage devices at home, we want to respond to all those queries right from the router. Whereas if there are questions around billing or bill explanations, so we respond to those questions from a model deployed onto the mobile device itself. So the way we sync with the data from the cloud remains the same, whatever the edge device is, and that ensures that we are responding to any type of queries that the customer has regarding their experience of the service. Now, in cases where there is a complex query, such as bill discrepancy, where some sort of downstream workflow is needed for either for credit or processing a credit or handing off to a customer care agent, so that's where we do the inference from the cloud, and that ensures that a more robust workflow will follow when we hit the cloud.
In one sentence or less ways, I'm going to give you the final word.
Sure.
How do folks learn more?
You can basically come to the booth, of course, right? If you are visiting AWS, and then of course we'll have a lot of content available online, right?
And you can check out more about this demo from our industry experts at AWS and Intel by checking out our showcase here in the AWS Village, or all the follow-up videos that will be capturing the demos in even greater depth. And until next time, gentlemen, thanks so much for joining us.
Thank you.
Thank you.